Hello everyone, welcome to a new session, a new problem and different solutions. So as always, first try to understand the problem and try the brute force approach, then you can optimize that. So today we will work on the valid anagram problem. Anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. For example, anagram and nagaram. So nagaram and anagram, you see, I don't think if it is a word, but here that is not the point. The point is to explain anagram. Like here you have 1A, 2A, 3A. 1, 2, 3. N, N, G, G, M, M. That is anagram. That means you created a new word just by rearranging the words of the letters of the first word. But here is not anagram. Here you have RAT, here you have CAR. If you had like this, RAT, like TAR, or art, for example, here, if you had art is anagram with rat. So now let's see how we can check that. So based on our knowledge of anagram, we need to check the count. First of all, we need to check the length of the two given words, because if the lengths are not the same, you don't need to check any further detail, because you already know that they are not anagram. Because anagram, they have the same length, just the place of the letters are changed, but the length is not changed. So first you check the length. If the lengths are not equal, no more checking, and you got the answer, they are not anagram. That's it. But if they have the same length, then you need to go a little further and study the details. So first check the first given words and see like the frequency of each letters. For example, here you have A repeated 3 times, N repeated 1 time, G repeated 1 time, M repeated 1 time. So if you got the frequency of letters in the first word, then you check that with the second word. So for example, let's have something like this. In Python we can call it a dictionary, something like this. So first, for the N, you have, so let's start from A. Is repeated 3 times, N is repeated 1 time, G is repeated 1 time, R is repeated 1 time, and M repeated 1 time. So see, in the first word, anagram, you got the frequency of the letters. Now you check this frequency should be the same as the frequency of the second word. If they have the same frequency, that means they are anagram. They have the same length and the same frequency, so that is anagram. So in the second, so first time you went through each of the letters and you add their frequency. For example, here you have A, so the first time you add the value number 1, like this, number 1, and then when you come to the second, you update this and make it 2, and you keep going through this, and when you come here on the third one, so you update this value and make it 3. It is how you can get the frequency in programming. I wrote down all this using with a human eye, and I saw like here is 1A, 1, 2, and 3. But in programming, you need to go through this, through all the letters, and count the number of each letters. And whenever you get the new one, so you just update the value. So when you get the second one, the first one, the frequency, the second one also, you need to go through each of them and compare that with this one. If you find out that they have the same frequency and the same length, so that means you have understood that they are anagram. So let's write that down, how we can do that. So before doing anything, we need to check the length of them. If length of first given word, if length s is not equal to length of t, return false. Return false. That means they are not anagram, and you don't need to check anything else. But if this condition does not meet, that means the length are equal, so you need to check the frequency of each letters. So first create a dictionary like this. Let's call it item count. So the first time it is empty. Now first go through the first word and count the frequency of each one here. For item n s, so right now the item count is empty, but you go through the letters, you update that. So you say item count of a, for example, like this, equals, so in the item count you need to check if a already exists or not. If it already exists, you just update the value. For example, like this. Right now let's actually make it empty. See, right now it is empty. We just created the dictionary here, and now we are at this point in the a item. The item is a, so we check, does it exist in this dictionary? No. If we say item count dot get item count dot get item, it will get the value of none. So since you cannot add none with integer numbers, so let's give it a default value 0. So it should be like digit number. So the first time when you check a, and it gives you the value 0, because here you got the default value. If you don't put this default value, it returns none, and you cannot, and later, for example, when you go to the second a here, so you cannot say like none plus 1. You cannot do this. For that reason, I'm giving here a default value that whenever an item does not exist in the dictionary, so it should return 0, a number. So later you can update that. So now that we are here, when we say item count dot get a, so it says that it looks in the dictionary and says that there is no a, so it returns 0. So, and when it returns 0, so we need to add a. We need to add a and put the value 1. So it is 0 plus 1. So same thing. Now it goes from a goes to n. Does n exist? Not yet. It returns none. Now with this 0 it returns 0. So again you can make 0 plus 1. So that means n also has the value 1. So again, when you go to the third one, in the a, this time when it says item count dot get item, so it gets a exists there, and when it say item.get item, it returns the value of 1. So you make it 1 plus 1. Now this one becomes 2. It is 2. Now we go to the third one, G. It is the first time. Then you go to the R, again first time. Then you go to the A. Again, when you say item count dot get item, it returns 2. So you make it plus 1 and make it 3. Okay, then you keep moving. Then you go to the M. So now it is the first time that you are adding M and you need to add M in the dictionary. So it is how you went through all the letters in this word and keep the count of their frequencies. So now you know that in the first word each letter how many times repeated. You can do the same thing with the second word. Make a separate dictionary and keep through each of the letters and keep the frequency of them. And at the end, just compare the two dictionaries. For example, if A in the first dictionary has the same value in the second dictionary, that means you have the same frequency. And you keep comparing all the elements. If everything are the same, that means that is an anagram. So you can do that one, or you can make use of this dictionary, because the second one, when you create, that should be the same. So if that is the same, why you are not taking use of this one that you have here? That way you can say that if there are any difference between them, so you just keep looking for those frequency difference. That means you start looping through these letters from here, from N. So you say that, well, does N in this dictionary exist? Yes, it exists. What is the value of N? 1. So you just subtract minus 1 from this value and make it 0, so that all the value should become 0. N here 1 time, and you subtract 1 time from this dictionary, so the value of N becomes 0. Then you go to A. So the first time when you are here, you subtract the value 1 from the value of A, it becomes 2. When you come here, you subtract, it becomes 1. And when you are here, you subtract again, A becomes 0. Then you keep going, G again. So if at the end all the value of in the dictionary becomes 0, that means they are anagram, because the same frequency you have, the same time that you keep adding number 1, now you subtract number 1. So let's go through the second one. For item in T, so you say that if item in dictionary, item count, if that exists there, so make the value minus 1, like this. Wait a second. So if item, first, and instead of that, you can check. For example, when you are here checking number N, you say if N does not exist in this dictionary, if item not in item count, return false. Return false. But if it exists there, so now you decrease its value. You say item count at item equals 1 minus 1, or you can say like this, minus equal 1. So it decreased the value one time, and you keep doing this until the value of every one of them becomes 0. So now you say that if item count is less than 0, return false. Return false. For example, at some point, let's say here you have 2n in the second word. The first time when you check the n and you make -1 in the dictionary, so it becomes 0. If there is one more n, and when you make the value -1, so it becomes -1. That means you have more n in the second word than the first word, or a or g. So that way you make it return false. But if the value is not less than 0, so you keep going through each of the elements, and at the end, if at no point you return false, at the end you say return true. Return true. Return true. Okay, now let's run this and see what happens. Yeah, both test cases passed successfully. So now let's submit this. Okay, accept it. So I hope it was clear enough. Only the second part was a bit trickier. Again, when you have more time, you can understand it. But in case you are under pressure, just the same way you created the dictionary for the first word, create a dictionary for the second word, then compare the value of two dictionaries. If they have the same values, that means they are anagram. If not, that they are not anagram. And until the next problem that we solve, have a nice time, everyone.